The physics of decentralized delay. A single millisecond of network jitter is enough to trigger a chain-wide fork in high-throughput consensus protocols. This happens because blockchains currently treat the physical internet as a black box, unaware of the congestion or routing failures happening at the packet level. Software-defined networking, or SDN, attempts to solve this by making the network programmable, but it usually introduces a central point of failure in the controller. Enter B-SDN, a framework where the blockchain and the networking layer are no longer strangers. New research released this June into Integrated Global Visibility suggests we are moving past the era where engineers have to choose between transaction speed and settlement finality. Decoupling the network brain. In traditional architectures, individual switches make their own routing decisions, which is why data can take unpredictable paths between validators. B-SDN decouples this by separating the control plane, which decides where data goes, from the data plane, which actually moves the packets. The blockchain acts as a decentralized auditor for these decisions, ensuring no single malicious controller can reroute traffic to censor transactions or isolate a segment of the network. Think of it as a global traffic map that every car agrees is accurate before they start driving. This structural integration allows the network to preemptively reroute block headers around congested nodes, which targets the primary cause of high orphan rates in decentralized systems. Solving the Latency Security Trilemma. Every consensus protocol faces a hard limit. As you lower block times to increase speed, the risk of temporary forks increases because some validators hear about new blocks later than others. B-SDN addresses this by using its global visibility to calculate the optimal propagation path in real time. By dynamically adjusting the network topology, it ensures that every validator stays within a tight latency bound, regardless of geographical distance. This directly challenges the assumption that decentralization must inherently be slower than a centralized database. The engineering trade-off shifts from how long we wait for consensus to how much bandwidth we are willing to dedicate to maintaining a high-fidelity network map. From overlay to native protocol. The real shift highlighted by current B-SDN research is that blockchains are moving from being an overlay on top of the internet to becoming a native component of networking infrastructure. By integrating programmable switches with on-chain consensus, we are seeing the emergence of a system where the network itself enforces its own security rules at the hardware level. This eliminates the need for massive, inefficient redundancy because the global visibility provided by the SDN layer allows for more surgical, high-speed validation. For protocol engineers and infrastructure operators, this marks a transition away from optimizing software code and toward optimizing the physical path of light through fiber. The signal under the noise is that the next leap in throughput won't come from a new Layer 1, but from the network cards and controllers that connect them. Watch for the standardization of B-SDN APIs across major data centers as the primary indicator of this transition. Subscribe for more.